Yeah, welcome to this webinar about advanced graph visualizations in Jupyter Notebooks. My name is Benjamin Niedermann. I'm an algorithm engineer at yWorks, a software company that is dedicated to create graph visualizations for your connected data. In this webinar, I will give an extended version of the talk that I gave at Notes 2024. And if you have some questions, so please feel free to use the chat or ask these questions below this video in the comment section. In this video, I would like to show you how to create not only beautiful, but also meaningful graph visualizations for your connected data. And with meaningful, I mean graph visualizations that you can actually use to derive new information from your connected data so that they support you in analyzing your data. And I don't want to do this on a theoretical level, but more on a practical level, showing you how to do this in Jupyter Notebooks and the environment of Jupyter. So Jupyter Notebooks is an interactive computing environment that you can use to analyze your data. What you can do is you can write in Python code that you then can execute on your data, and then you get some result, and then you can continue working on this result again, executing Python code, applying different algorithms to analyze your data. So this is a system that became very popular for data analysis. And of course, somehow you need to get in the data into the system. And one possibility is to use databases like Neo4j databases. Then, of course, sometimes it's also useful and helpful to visualize your data, and the environment of Jupyter Notebooks offer you different possibilities to do this. And also we developed one component that you can use to visualize your data, and we developed this component based on yFiles, so the main product of yWorks, which is a software library that you can use to automatically visualize graphs. And in today's webinar, I would like to show you how to set up this pipeline and how to use it to create graph visualizations for your connected data so that you can actually learn something from these visualizations for your data. And I would like to do this on an example based on a music database. In other webinars before, I already used this example. This stems from discogs.com. It's a music database which is Wikipedia-like and which is maintained by thousands of users. And it contains millions of releases and entries about releases, and also millions entries of descriptions about the artists and labels. So if you go to this website, what you can do, you can explore this database by going to single entries, and then you can click through these entries by clicking on some of the links, and so that you can hop from one entry to the next, getting some information about the single entries. But sometimes, of course, it would be also nice to learn something about the relations between the entries. And here, graph visualizations come in. And the question is, how can we visualize the relations in such a large database with millions of relations? And the answer is, I think, this is probably not the right question, because when you try to visualize every relation, what you get is a really large hairball of edges and nodes in your visualization, so that you can't analyze the single relation anymore. What you could do is you could aggregate the visualization or the data a bit, so that you get only a rough overview of the data, but it's not possible to see all relations at one time. So maybe here we need to ask another question, namely, what would you like to learn from the visualization? And starting from there, we can then decide how to create the visualization. So what I did is I went to my colleagues and I asked them what would they like to learn from such a visualization, and they came up with different answers. So someone said, I would like to learn about the history of my favorite artists. Another one said, okay, who I would like to learn about who has collaborated with whom. And then there was also someone who said, okay, I would like to learn something about the spatial patterns among my favorite artists. And then there was also the question, in which genres have my favorite music groups released their work? And then finally, there was also the question about the connections between the genres. So looking at these questions, it's obvious that we don't need to visualize the entire database, but it suffices to visualize a subset of the database, namely, for example, about the favorites of my colleagues. And then we can also think about certain relationships, and we don't need to visualize all of the relationships. And the idea of this webinar today is that I show you how to do this. So what I've done at the very first step is I extracted a much smaller snapshot of this database, which basically is sufficient to answer these questions. So what I did, I started with the favorites of music groups and artists with some of them, and then I extended this graph by also adding further music groups that are related to the favorite music groups. And this gave me a base data set with 59 artists and 152 music groups. Also, what I did, I extracted additional data about the genres, and I also annotated the data with the cities in which the artists are born. And this gave me 51 cities, so some of the artists are obviously born in the same city. And then finally, I also extracted the relations, which gave me 665 relations. And this is the graph that I would like to use to answer the questions that I've shown before. And I would like to do this using Jupyter Notebooks. The structure of the graph looks as follows. So what we are given is are nodes that are or represent artists. We also have nodes that represent groups, nodes that represent genres, and nodes that represent cities. And then we also have some relations between these nodes. Between artist and group nodes, we have the relation member of. So an artist can be member of a certain music groups or of multiple music groups. Music group also publishes releases in genres, and the genres have common styles. And then also what we have is that an artist is born in a certain city, and this is basically the schema of our database. And based on this data, I then created a Neo4j database, and then I set up a Jupyter Notebooks environment, connecting this to the Neo4j database, and then I started visualizing the data. So what I did is I created basic visualizations describing certain relations between the genres, but I also used visualizations showing temporal relations, spatial relations, and what I also will show is how to apply graph data science to analyze the data and also to visualize the result then in the visualization. So let's go to Jupyter Notebooks and let's see how you can do this in practice. So here you can see the Jupyter environment. So what I use is Jupyter Labs. And so this is a typical view on this. What you can see is here some coding blocks filled with some Python. And now what you can do is you can execute these Python blocks step by step, gaining every time some new results, and then the next block can build up on these results, and this helps you to analyze your data. So in these blocks, what you can see is how to establish a connection to a database, and then also to set up the widget for visualizing the graphs. So the first block is about setting up the database. As I already said, I use a Neo4j database. So what I do is I import the module Neo4j, and from this I import the class graph database. And for this this graph database I can use to set up a session. For this I need the credentials of the database, and then I already have set up this session. So the next step is that I import the widget that I would like to use to visualize the data. So in this case, I use the yFiles Jupyter Graphs for Neo4j widget. You can easily install it using the pip command, install and then yFiles Jupyter Graphs for Neo4j. I've already done this beforehand. And now what we need to do is also to load the Neo4j graph widget from this module, which we can do with this line of code. This is everything that you need, that we need to set up the database and also to set up the sys or environment for creating visualizations. And now we can start creating visualizations. So let's go to the very first and simple visualization. So what I would like to do is I would like to visualize the relations between artists and music groups. So I ignore the other data in the database and focus only on these relations. So to that end, I can create a graph widget, here the Neo4j graph widget. I need to pass the driver to tell the widget which database it should use. And then I can call the widget with a Cypher query. And in the background of this widget, then the database is queried with this statement here. And then the returned data is visualized. So the query is quite simple. It just says that I would like to query all relations R between artists and music group nodes, and then I return these entries that I just queried, and the widget then automatically visualizes the data. So let's have a look at the visualization. Here you can already see the graph visualization of this query. And this widget here supports different operations. So you can hover over these elements, as you can see. And then you get also information about the single entries when hovering above a single entry here. Of course, you can also navigate. So it supports the typical navigations like zooming or panning, which helps us to explore the visualization. And what you can also do in this widget is you can apply different layouts. So for example, what you can do here is you can apply, let's say, a tree layout on this visualization. And the visualization is created live on this computer, so it's not pre-computed, but yFiles just computes this on this machine. It's also important to say that the data stays on the machine. So when the data is received from the database, the entire computation is done here. The tree layout obviously is not the best choice for this kind of data. This I just have shown for an example. So let's let's go back to the organic layout, which is again computed live on this machine here. And this is the way how you can create graph visualization. So this was the very first and simple example how to do this. Of course, it would be also nice to configure this visualization. So often you want to encode information in the visualization. So for example, by changing the color or the shapes of the nodes and edges. And you can also do this with a widget. And I would like to show you this in the next example. Here, the idea is that you can add node configurations and relationship configurations. Node configurations change the visual appearance of nodes, and relationship configurations change the visual appearance of edges. So let's have a look at the node configurations. Here, the idea is, for example, that an artist node should get a round rectangle as a shape. Let's have a look at the visualization. Yep. So if I zoom in to Robbie Williams, we see, okay, the shape of Robbie Williams is now a round rectangle. And then I also changed the color, so I've defined this above in a basic definition section, the colors, and in this case, it's a blue color. For music group nodes, I did the very same. I changed the color and I said, okay, the shapes should be circular. And yeah, that's all. And I also defined the sizes. Besides that, I also said, okay, the text label of the nodes should be the name. So if I hover over one of these nodes, what you can see that each entry is annotated with further information, for example, also with a name. And the idea is that when the visualization is created, the visualization looks up this property name or the property with a key name and then takes the content and uses this as a label. Yeah, that's basically how we can basically define configure nodes. We can also configure relationships. So for example, the relationship member of. So here we set the color to member of color and then also the thickness factor so that we say, okay, it's 2. So let's have a look again at this visualization. I can also recreate this visualization by executing this again. And what we can see when we look at this visualization now, it's quite easy to distinguish between music group nodes and artist nodes. And what we can also easily see, okay, it consists of one large component and 3 small components. And now we can start exploring this data. This is a quite simple kind of visualization, and now I would like to go to a bit more complicated visualizations. So what I would like to do is I would like to answer or find answers for the questions my colleagues had beforehand, and I would like to start with analyzing the genres which are found in the music database. So the first question is, how are genres related to each other? So this time I would like to focus on genre nodes. So I ignore all other data and I just focus on the common styles between the genre nodes. I will first go to the visualization so that you get an idea how I would like to visualize the data. And then after that, I explain how I've created this visualization. So let's go to the visualization. I just execute this Python code here. I get this visualization here. Scroll down a little bit so that you can see this better. So the idea is that each genre node is placed on a common circle so that we can easily see which genres are in this music database. And then what we also can do is we can connect the music group nodes, the genre nodes with each other. Expressing how many styles they have in common. So for example, electronic and the genre folk, world and country have a lot of common styles, namely 372. But there are also some genres that have only few styles in common. So for example, blues and electronic. So this visualization already gives you a good idea how these genres are related to each other. And this very simple visualizations of the edges also shows you how strong the relation is. So this is an idea how you can visualize the genres in order to answer this question, how the genres are related to each other. By the way, sometimes it's also useful to export these kind of graph visualizations. So for example, for a presentation, or you would like to continue working on these visualizations, you can actually do this with the graph widget. What you can do is you can click here. So for example, on export to yFiles. And if I do this, the entire visualization is loaded. So I load this. I continue with the current theme. And now I can edit this visualization using yFiles. yFiles is a free tool that is also based on the yFiles library for graph visualizations. And it's fully grown in the sense that you can change the graph, you can edit the graph, and you can also apply other layouts. So for example, you can go here to the layout section, and then you can choose from one of these other layouts. So let's say to the orthogonal layout, and then you could apply this. But you can also edit single elements here. For example, you could say, okay, maybe I just want to change some of the labels. So I could say, okay, I would to select similar labels, so all edge labels, and I'm not interested in these edge labels, so I can remove them. So you can fully edit this visualization. This just as a short side note, how you can continue working on these visualizations. So let's go back to Jupyter Labs. And let's go to the source code. So what I do is I again need to query the database. And again, the query is quite simple. It's just that I query the shower nodes and the relations between the shower nodes. And then I return the entries that I get from the database, and the visualization then just creates this circular layout here. So of course, we somehow need also to specify that we would like to use the circular layout. And for that, you can define the parameter layout. And this time I use circular straight line layout. There are also other layouts, as you will see later. And now what I also do is I change the configuration for the relationship. This time the thickness factor of the edge is not fixed, but depends on the edge and the properties annotated at this edge. So what I can do is instead of just defining a number, I can define or pass a lambda function that returns for an edge a number, and this time I just return the number of styles. So I can access this by accessing the properties of the edge, and then there's the property styles, and then I also do some scaling so that the edges do not become too thick. And this is everything that I need to do to create this kind of visualization. So let's go to the next visualization. So in this visualization, I would like to focus on the question which genres are preferred. So on the questions which genres are important in this data set. What I want to do is I want to only focus on music group nodes, on genre nodes, as well as on the relation place, which expresses which music group node have published releases in which genres. So the idea is now that I will create the visualizations in two steps. In the first step, I will analyze the importance of the genre nodes using graph data science and PageRank. And then in the second step, I will use these results in order to visualize the importance. So let's have a look at the first step. Here I use graph data science, which is a module with different types of graph algorithms that you can use to analyze graph data. What you need to do is, again, to set up a connection to your database by passing the credentials of the database. And then you have this object GDS, and with this you can start analyzing the data. Typically, what you need to do is you need to project your graph in the graph database maybe on another graph expressing other information. In this time, it's quite simple, this projection. I just want to restrict the entire graph to group nodes, genre nodes, as well as the relation place, which I can do here in this line using the function project. And this projection is then called music projection. And then in the next step, I can apply PageRank, and PageRank is an algorithm that assigns to each node in the network the importance of the nodes with respect to the relations. And this number I then can use to visualize the importance of the nodes. So what I do in the last step of this step is I create a dictionary of these page ranks, so that and this dictionary basically then contains for each node a number, and this number expresses the importance of the node. And now in the second step, I would like to visualize this data. And again, I would like to first show you the visualization, and then I explain you this code, because then you already have an idea what I want to show in this visualization. Here you can see the result of the visualization. The red nodes correspond to shower nodes, and the blue nodes correspond to music group nodes. And what you can see here is that shower nodes have different sizes. So rock, for example, has a large size and jazz has a small size. So this expresses the importance of these nodes within that network. For the music group nodes, I always have chosen the same size because here I don't want to express any importance. Besides that, what you can also see is the relations between these two types of nodes. What you can see here is that there are many music groups that only publish in the genre rock, or for example, also in the genre pop. But there are also music group nodes that publish in exactly both of these genres, but not in other genres. So this is a quite nice visualizations where you can get this information easily from. So now let's have a look at how to create such a visualization. Again, it's about changing node and configurations and relationship configurations. I will start with the node configurations, and here it will be about mostly defining lambda functions that depend on the data of the node. I start with the shower nodes. It's much more interesting than the group nodes, and then the very same is basically done, or similarly, the group nodes are configured. So let's have a look at the shower nodes. Here the idea is that we need to define a label and a size of the node. So let's have a look at the size. Here I just use the function getSize as a parameter, and this size is defined here. So it expects a node, and then for this node it computes a scale in this function getScale, and then I also return the scale for both dimensions, so for the width and height of the node. And I also do some scaling that I've just applied to obtain a visualization that has not too small nodes. So let's have a look at the getScale function. Here, what I do is I query the rank. So first of all, I query the ID of the node, and then using this ID, I query the ranks that I've just computed in the step before, and then I return the rank. And this is done based on a simple function based on the square root in order to obtain different node sizes that are monotonically grow with a rank, but not too much. And this is everything that I need to do to define the sizes. Then for the text, I can also define a function getText, which depends on the scale. So I also change the font size of the node, of the label, depending on the importance of the node. So then it really becomes clear for the viewer, okay, this is probably an important node. And for the node configurations of the music groups, I apply the very similar approach, but here the difference is that the size is not fixed, it's not variable depending on the page rank, but it's just fixed. And this is everything I need to do to define the visualization. And then what I also do is I need to start the visualization. Here what I do is I started with a query that just queries all relations place and returns the source as well as the target nodes and the relation, and then I create this visualization. And I also say, okay, I would like to use the organic layout of yFiles. So this is how to do this using graph data science. And now I would like to go to the next example. This time I would like to talk about spatial hotspots. So I would like to visualize the spatial data behind the graph that we are given in the database. And this time I would like to focus on the artist nodes, on the music group nodes, and the city nodes, so in which the artists are born in. And again, I first go to the visualization, explain this, and then I explain the Python code. So what you can see here is a map of the world, and each node here corresponds to one city in which an artist was born. And the edges then also show the relations between the artists. So two artists have worked together when there's an edge. And this gives us a collaboration network that has also a spatial component. So I can zoom in here, for example. And what I can see here is that there are 4 artists that have worked together, or maybe also more. But if you have a look at the data, then you will see, okay, it's exactly 4. Namely, this was ABBA, a Scandinavian music group. What you can also see here in this visualization is a heat map behind this, behind the nodes. The idea of this heat map is that it shows the number of releases so that it also visualizes basically the hotspots, the spatial hotspots in this visualization. And now I would like to show how to create this visualization. First about the query. It looks quite complicated, but it's not that complicated. You can have a look at this later on. It's just that I need to create a new graph where I project the collaboration network of the artists onto the city node. So basically what I do is I say, okay, I would like to introduce connections between the city nodes, so the nodes representing the cities, when there was a collaboration between the artists. And most of the code is also about copying properties so that the cities then also have the information the artists also have. A special thing here is maybe also to mention is that when projecting this graph, we don't change the database, but we do this on a virtual level. So what we do is we create virtual nodes and virtual relationships only present for the visualization. So besides this Cypher query, what we also need to do is we need to configure the visualization, and I would like to focus on this configuration. As you have seen, there are 2 things that we need to define, namely the location of the nodes. Namely, we need to say where to place the nodes on the map. And then I also would like to define the heat mapping. And again, we can do this using Lambda functions, or just by passing functions that we've defined before. And this time what we can do is we can define the parameter coordinate, which defines then the coordinate on the world map. And then we can also define the heat map. So let's have a look at the coordinates for the city nodes. This is just calling the function location, which returns for each node the property coordinates. And in the very first step, when I created these databases, this database, I annotated each city with its coordinates, with longitude and latitude. And this is just returned here for each node. And for the heat mapping, it's also quite simple. We just need to return for each element of each node of this graph visualization a number expressing the importance of this node. And this time what I do is I take the number of total releases, and then I normalize this value with respect to the other number of releases for each element, and then I return this normalized value. And this is everything that I need to do to create this heat map showing me the spatial hotspots. Yeah, and this is how you can configure such a visualization. So next, now I would like to go to the next visualization, which is not about spatial components, but about temporal components. And here I would like to show first a small sketch, what I would like to visualize, and then I can explain how to do this. In this visualization, the idea is that an artist is not represented by a single node, but by an entire path in this visualization. So, for example, if you have a look at Paul McCartney, Paul McCartney is represented by the blue path through this visualization and goes from one music group to another. So Paul McCartney goes first to the music group Beatles, and then to the music group Linda and Paul McCartney, and then to Wings. And the idea is that the order of the music groups corresponds with the date of the first release of the music group. And I don't do this only for Paul McCartney, but for all of the artists. And this gives me a quite interesting visualization, which tells me something about the history of the artists. So again, I first show you the visualization, and then I explain the Python code. So this is the visualization. I can also create this live on this computer. It's quite fast. As you can see, here is we get an hierarchic layout. And I can zoom out a bit so that you can see the entire graph. And this shows the entire database behind this using relations between artists and music groups. What you can also see is that there are quite large nodes and then also small nodes. So what I've done is that the music groups are represented by these lilac nodes, and then the artist nodes are represented here by these blue nodes here. And also depending on the number of releases, they have different sizes. And now what I can do is I can go to one of the artists, so let's say in Paul McCartney, and now I can follow the path of Paul McCartney to the different groups. So he was member of or is member of the Quarrymen, and the first release of the Quarrymen was before the first release of the Beatles. It comes before the Beatles on this path. So I can continue following this path here, following Paul McCartney, and then I find out, okay, Paul McCartney is also a member of the group Paul and Linda McCartney. And so I can explore this visualization. Besides that, I can also see the importance of the impact of the music groups. So the size of the nodes represent the number of releases published by these music groups. And this gives you a quite interesting visualization on how to create or on how artists have collaborated over time. If you are interested also in exploring different ways on how to visualize this kind of data, I also recommend you to have a look at our other webinars about the art of graph visualizations. Here I've used the data set for another types of visualizations and also using different types of platforms. So for example, yFiles HTML to visualize the data. So let's have a look at the Python code, how to create the visualization. Again, the Cypher query is a bit more complicated, so just take your time and have a look at this. It's when you get it's not that complicated if you get the idea. The idea is that for each artist we need to create a path. And we want to visualize this path through these music groups. So what we can't do is we cannot take the input graph directly, but we need to restructure the input graph. And again, what we do is we introduce virtual relationships representing these paths. So basically what we do is we query the artists and music group nodes. We sort the music group nodes by their first releases, and then what we do, we insert these paths of the artists and insert them into the database and as a virtual relationship. And then we use these relationships in the visualizations. And at the end, we also say, okay, we would like to use a hierarchic layout and not, for example, an organic layout. Why in hierarchic layout? The hierarchic layout is good for visualizing acyclic graphs because it really tells me an order, or gives me an order on the nodes with respect to the path. So I know that it expresses the temporal component, which is encoded in this path of the artists. Beside this query, the remaining configuration is quite simple. Again, we need to define the group sizes. So for each music group, we define it's not the number of releases, but it's the number of genres in which they have published their work. And then for each artist, we also show the number of releases. And this is again inserted into or is used for the node configurations. For the edge configurations, we use the part of storyline relation. This is again not part of the database, but this is created as a virtual relationship in this Cypher query here. And maybe you've also noticed this function here. It says node to cell mapping. And what we also do is in the background, we insert a partition grid. So basically a table structure. And this table structure says that all artist nodes are placed in the very first row and all other nodes are placed in the second row of this table, which gives me then a clear difference or local distinguish difference between artist nodes and music nodes. So just to make this clear what this means, so let's have a look at this visualization here again. What you can see here is that all artist nodes here are placed in the very first row. And this is not by accident. This is because we have defined this cell mapping. And then all other nodes are placed below this first row. And this is done here by this cell mapping. So it says place the artist nodes in the first row and place all other nodes in the second row. I can just comment this out for a moment. Here I can define this node cell mapping. I just comment this here out and then I execute this visualization again. And now what we can see is that the artist nodes are not placed anymore in the same row, but they can be placed anywhere in the visualization, still maintaining, of course, the temporal or maintaining the temporal relationships. So let's do this, or let's revert this again. And now we get the original visualization. And this should have shown you how to do also more complicated visualizations in Jupyter Notebooks. If you have further ideas how to create visualizations where you also want to configure more things, what you can also do is you can, for example, go to our playground on our webpage, and there you have the entire power of yFiles in this playground, and you can start creating visualizations, or you just use our SDK. So let's go back to the slides. So in this webinar, you've seen how to set up a simple pipeline that you can use to visualize your connected data. It supports you in analyzing your data. And the idea was to set up a pipeline between a database, Jupyter Notebooks, and our component for visualizing the data as graphs. Here, the idea is that you formulate a Cypher query that is used to query the database, and then the result is visualized in our component, and you can configure this component by changing, so for example, the styling of the nodes as well as the edges, changing the layouts. And this gives you the possibility to encode further information in the visualizations so that you can learn new things from the visualizations. All the tools that I've presented here are free to use, so that you can directly start with them. And if you are interested in the examples that I've shown in this webinar, I invite you to have a look at the Jupyter Notebooks that you can find on Google Colab. And if you're interested in more examples, you can also find some on our GitHub repository, where you can also find examples for different use cases. So with this, I would like to end this webinar. I thank you for your attention and I wish you happy diagramming.